about a couple of ways of solving quadratic equations. We've solved quadratic equations by factoring and using the zero product principle, and we've used the square root property. In this lesson, I'm going to introduce the quadratic formula and do some examples. Steve's going to do some more examples with the quadratic formula, and then Anne's going to talk about making choices about which method to use. So, what is the quadratic formula? To solve a quadratic equation of the form ax squared plus bx plus c equals 0, use the formula x equals the opposite of b plus or minus the square root of the quantity b squared minus 4ac all over 2a. It's really important that you memorize this formula, and you should start working on this right away. As you're doing problems in your homework where you're using the quadratic formula, it's a good idea to write the quadratic formula down on your piece of paper each time you do a problem. This might help in memorizing. So let's do an example. Let's use the quadratic formula to solve x squared minus 7x plus 12 equals 0. I solved this in an earlier lesson by factoring and applying the zero product principle. So we have a quadratic equation in the form ax squared plus bx plus c equals 0. To use the quadratic formula, I need to decide what a, b, and c are. Well, a is the coefficient of x squared. In this case, that's 1. b is the coefficient of x. In this case, that's negative 7. And c is the constant. In this case, that's 12. So I need to apply the quadratic formula. You should write this down on your paper. So x is going to be the opposite of b, that's the opposite of negative 7, plus or minus the square root of the quantity b squared, so that's the square of negative 7, minus 4 times a, which is 1, times c, which is 12. And all of this is over 2a. In this case, that's 2 times 1. So let's simplify. The opposite of negative 7 is 7. Plus or minus the square root of squaring negative 7, I get 49, minus 4 times 1 times 12 is 48. And in the denominator, I just have 2 times 1, which is 2. So this is 7 plus or minus the square root of 1 over 2. Well, what number squared gives me 1? 1 squared is 1, so the square root of 1 is 1. So I have 7 plus or minus 1 over 2. So I actually have two equations here. X equals 7 plus 1 over 2, which is 8 over 2, which is 4. Or x equals 7 minus 1 over 2, which is 6 over 2, which is 3. Of course, now I need to check my solutions. So if x equals 3, then x squared minus 7x plus 12 is 3 squared minus 7 times 3 plus 12. That's 9 minus 21 plus 12. 9 plus 12 is 21. 21 minus 21 is 0. That's what I wanted here. X squared minus 7x plus 12 to equal 0. So my first solution checks. What about 4? Well, if x equals 4, then x squared minus 7x plus 12 equals 4 squared minus 7 times 4 plus 12. That's 16 minus 28 plus 12. 16 plus 12 is 28. 28 minus 28 is 0. That's what we wanted. So both solutions check. Now I need to remember to write my conclusion. The solutions are 3 and 4. So now let's use the quadratic formula to solve 1/2 x squared plus 5/2 x minus 3. While it is true that our equation is in the form ax squared plus bx plus c equals 0, it's going to be a bit of work using the quadratic formula with values of a and b, which are fractions. So I think what I'm going to do first here is clear the fractions. So I have 1/2 x squared plus 5/2 x minus 3 equals 0. To clear the fractions, I can multiply both sides of the equation by 2. When I multiply 0 by 2, I still get 0. What about on the left-hand side? When I multiply 1/2 x squared by 2, I just get 1x squared. I've cleared the first fraction. When I multiply 5/2 x by 2, I just get 5x. I've cleared the second fraction. And I can't forget to multiply -3 by 2. -3 times 2 is -6. So now I see that I have an a value of 1, my coefficient of x squared is 1, a b value of 5, the coefficient of x is 5, and a c value of -6, since the constant is -6. Now when I apply the quadratic formula, I get x equals the opposite of b, that's -5, plus or minus the square root of b squared, that's 5 squared, minus 4ac, that's 4 times 1 times -6. All over 2a, that's 2 times 1. So let's simplify this. So I have -5 plus or minus the square root of 25 minus 4 times 1 times -6. That's the same as plus 24, all over 2. So that's -5 plus or minus the square root of 49 all over 2. 49 is a perfect square. So I have -5 plus or minus 7 over 2. So I either have x equals -5 plus 7 over 2, which is 2 over 2, which is 1, or x equals -5 minus 7 over 2. That's -12 over 2, which is -6. Of course, I need to check these solutions, and it's important to go back to the original equation to check the solutions. So if x equals -6, then 1/2 x squared plus 5/2 x minus 3 equals 1/2 times the square of -6 plus 5/2 times -6 minus 3. The square of -6 is 36, and half of 36 is 18. Positive 5/2 times -6 is going to give me a negative result. 2 goes into 6 3 times, and 3 times 5 is 15. So I have 18 minus 15 minus 3. That's 18 minus 18, which is 0. That's what we wanted, so this checks. I still need to check x equals 1. So if x equals 1, then we have 1/2 x squared plus 5/2 x minus 3 equals 1/2 of 1 squared. 1 squared is 1. 1/2 times 1 is 1. Plus 5/2 times x, that's 5/2 times 1, which is just 5/2, minus 3. 1/2 plus 5/2 is 6/2. 6/2 is 3. 3 minus 3 is indeed 0, so this solution checks as well. So I can go ahead and write the conclusion. The solutions are -6 and 1. Now let's use the quadratic formula to solve 2x squared plus 9x minus 3 equals 2. Well, the first thing I'm noticing here is that I don't have the form ax squared plus bx plus c equals 0. But it's going to be pretty easy to rewrite this equation so that one side of the equation is 0. All that I have to do is subtract 2 from both sides of the equation. Subtracting 2 from both sides of the equation gives me 2x squared plus 9x minus 5 equals 0. And now I see that a, the coefficient of x squared, is 2, b, the coefficient of x, is 9, and the constant c is -5. So, pulling out that quadratic formula, which you should write it on your paper to help you memorize it, we know that x is going to be the opposite of b, so that's -9, plus or minus the square root of b squared, that's 9 squared, minus 4ac. In this case, that's 4 times 2 times -5, all over 2 times a, which in this case is 2 times 2. So let's simplify. So I have negative 9 plus or minus the square root of 81 minus 4 times 2 times negative 5, that's going to be positive 40, all over 4. So I have negative 9 plus or minus the square root of 121 over 4. 121 is a perfect square. 11 squared is 121. So I have negative 9 plus or minus 11 over 4. So either x is negative 9 plus 11 over 4. That's 2/4, which is 1/2. Or x is negative 9 minus 11 over 4. That's negative 20 divided by 4, which is negative 5. I still need to check the solutions. So what if x is 1/2? Then 2x squared plus 9x minus 3 is 2 times 1/2 squared plus 9 times 1/2 minus 3. So that's 2 times 1/4 plus 9/2 minus 3. In the first term, I can pull out a factor of 2 over 2, since 4 is 2 times 2, and that leaves behind a 2 in the denominator and a 1 in the numerator. 2 times 1/4 is 1/2, plus 9/2 minus 3. 1/2 plus 9/2 is 10/2. 10 divided by 2 is 5. So I have 5 minus 3, which is 2. Looking at my equation, that's what I wanted. I wanted 2x squared plus 9x minus 3 to equal 2. So my first solution checks. What about if x equals negative 5? Then we have 2x squared plus 9x minus 3 equals, doing a little arithmetic in my head here, when I square negative 5, I get 25, plus 9 times x, that's 9 times negative 5, will be negative 45, minus 3. So I have 50 minus 45 minus 3. That's 50 minus 48, which is 2, and that's what we wanted. So both of the solutions here check, and I can go ahead and write my conclusion. The solutions are negative 5 and 1/2. Now let's use the quadratic formula to solve x squared plus 12x equals 0. So we're going to have a quadratic equation in the form ax squared plus bx plus c equals 0. So a, in this case, the coefficient of x squared, is 1. B, the coefficient of x, is 12. And I can think of this equation as x squared plus 12x plus 0 equals 0. So my constant is 0. C is 0. So pulling out the quadratic formula, which you should write on your paper, we have x is going to be the opposite of b, so that's negative 12, plus or minus the square root of b squared, that's 12 squared, minus 4 times a, which is 1, times c, which is 0. All of this over 2 times a, which is 2 times 1. So let's simplify. So I have negative 12 plus or minus the square root of 144, that's 12 squared, minus 4 times 1 times 0 is 0, all over 2. So this is negative 12 plus or minus the square root of 144 over 2. So that's negative 12 plus or minus 12 all over 2. So either x equals negative 12 plus 12 over 2, that's 0 over 2, which is 0, or x equals negative 12 minus 12 over 2. That's negative 24 over 2, which is negative 12. What if I had factored to solve this problem? I could factor out a common factor of x, and I'd have x times the quantity x plus 12 equals 0. And using the zero product principle right away, that would lead me to the solutions x equals 0 or x equals negative 12, which is what I just got. However, this problem did say use the quadratic formula to solve this. And I did that so that I could show you that the quadratic formula works on any quadratic equation. In this case, it would have been a lot easier to factor, and if I had been given a choice, I would have factored. But if your problem says use the quadratic formula, you need to actually use the quadratic formula to show your teacher that you can. I do need to still check these answers, negative 12 and 0. So if x equals negative 12, then x squared plus 12x is the square of negative 12 plus 12 times negative 12. The square of negative 12 is positive 144, and 144 minus 144 is 0. So that checks. I think I'm going to do the other check in my head. Look what I'm checking. 0. If I replace x with 0, 0 squared is 0, plus 12 times 0, that's 0. 0 plus 0 is indeed 0. So both of my solutions check. So I'm going to go ahead and write the conclusion. The solutions are negative 12 and 0. Now let's use the quadratic formula to solve x squared equals 25. I don't have an equation in the form ax squared plus bx plus c equals 0. So the first thing I need to do here is get this so that I can write my equation with 0 on one side of the equal sign. All I have to do is subtract 25 for both sides of the equation. So x squared minus 25 equals 0. So a, the coefficient of x squared, is 1. And I could think of this equation as x squared plus 0x plus 25 equals 0. And I say that the coefficient of x is 0. So b is 0. My constant is negative 25. So c is negative 25. Now pulling out the quadratic formula, x is going to be the opposite of b. So that's the opposite of 0, which is still 0, plus or minus the square root of b squared, that's 0 squared, minus 4 times a, which is 1, times c, which is negative 25. All of this over 2a, which is 2 times 1. Let's simplify. The opposite of 0 is 0. When I add 0 to the square root, or 0 minus the square root, I'm not going to change the value. So I just have plus or minus the square root of 0 squared is 0. Negative 4 times 1 times negative 25 is 100. 0 plus 100 is 100. So I have plus or minus the square root of 100 all over 2 times 1, which is 2. So this is plus or minus 10 over 2, which is plus or minus 5. It looks like I'm getting solutions of 5 and negative 5. What if I had factored on this problem? You might have looked at this problem and said, this problem looks pretty easy. I think there's another way I can solve this. Well, if I had factored, I would have had a difference of squares, and I would have factored this as x plus 5 times x minus 5 and come up with the solutions of negative 5 or positive 5. Same things I got. What if I had used the square root property? Well, then all I would have to say is x equals plus or minus the square root of 25, which is x equals plus or minus 5. Either factoring or the square root property would have been quicker methods for solving this equation. But again, I was asked to use the quadratic formula to solve this equation. When your directions tell you to use the quadratic formula, that's what you need to do, even if you see an easier way of solving the problem. I do need to still check my solutions. I think I can check both of these in my head. Whether I square a positive or a negative number, I'm going to get a positive result. So if I square negative 5, or if I square 5, I get 25. That checks. So the solutions are negative 5 and 5. Now let's use the quadratic formula to solve 12x plus 9 equals negative 4x squared. I definitely don't have a quadratic equation in the form ax squared plus bx plus c equals 0. Well, what can I do to rewrite this equation so that it is in that form? I need one side of the equation to be 0. The easiest way to do that is to add 4x squared to both sides of the equation. So 4x squared plus 12x plus 9 equals 0. So we see that a is 4, b is 12, and c is 9. Pulling out the quadratic formula, we know that x is going to be the opposite of b, that's negative 12, plus or minus the square root of b squared, that's 12 squared, minus 4 times a, which is 4, times c, which is 9, all over 2 times a. In this case, that's 2 times 4. Let's simplify. This is negative 12 plus or minus the square root of 144 minus 4 times 4 times 9 is 144, all over 8. So I have negative 12 plus or minus the square root of 0 over 8. What number squared gives me 0? Well, 0 squared is 0. So the square root of 0 is 0. And whether I add 0 to negative 12 or subtract 0 from negative 12, I'm still going to have negative 12 in the numerator. So this is negative 12 eighths, which reduces to negative 3 halves. It's looking like I only have one solution here. The radicand in this problem is 0, which causes this equation to have only one solution. I do need to check that one solution. So if x equals negative 3 halves, well, going back to the original equation, it looks like I need to check both the left and right hand side of the equation and make sure I get the same result when x is negative 3 halves. So starting with the left hand side, 12x plus 9 is going to be 12 times negative 3 halves plus 9. 2 goes into 12 6 times. 6 times negative 3 is negative 18. Negative 18 plus 9 is negative 9. Now I don't know if this checks until I look at the right-hand side of the equation. So negative 4x squared, when x is negative 3 halves, is going to be negative 4 times the square of negative 3 halves. That's negative 4 times 9 fourths. Pulling out a factor of 4 over 4, I'm left with 1, 4 over 4 is 1, times negative 9, which is negative 9. Now looking back, both the left-hand side of the equation simplifies to negative 9, and the right-hand side of the equation evaluates to negative 9 when x is negative 3 halves. So my one solution checks. The solution to this quadratic equation is negative 3 halves. Now let's use the quadratic formula to solve 3x squared minus x plus 5 equals 0. This equation is in the form ax squared plus bx plus c equals 0. A is 3, b is negative 1, and c is 5. Pulling out the quadratic formula, we have x is going to be the opposite of b, that's the opposite of negative 1, plus or minus the square root of b squared, that's going to be the square of negative 1, minus 4 times a, which is 3, times c, which is 5, all over 2 times a. In this case, that's 2 times 3. Let's simplify. The opposite of negative 1 is positive 1, so we have 1 plus or minus the square root of the square of negative 1 is 1, minus 4 times 3 times 5, that's 60, all over 6. So I have 1 plus or minus the square root of negative 59 over 6. What real number squared gives me negative 59? Well, if I square a positive number, I get a positive number. If I square a negative number, I get a positive number. If I square a 0, I get 0. There is no real number that I can square and get any negative number. In this case, the radicand is negative, which causes this equation to have no real number solutions. So there are no real number solutions. Well, let's take a closer look at this radicand. The radicand, b squared minus 4ac, in the quadratic formula is called the discriminant. If the discriminant is positive, then the equation has exactly 2 real number solutions. If the discriminant is 0, then the equation has exactly 1 real number solution. We saw that a couple of examples ago. And in the last example we looked at, the discriminant was negative. In that case, there are no real number solutions. So in this example, we're asked to determine how many real number solutions each equation has. Notice we're not asked to find the solutions, we're just asked about the number of solutions. So the only thing we have to consider here is the discriminant b squared minus 4ac. Starting with x squared minus 6x plus 9, b squared minus 4ac, in this case is the square of negative 6 minus 4 times 1 times 9. That's 36 minus 36, which is 0. The discriminant is 0. So in the quadratic formula, when we take plus or minus the square root of b squared minus 4ac, we're going to be adding and subtracting 0. That causes the number of solutions to be just 1. So there is exactly 1 real number solution. What about 2x squared minus 3x plus 4 equals 0? Well, in this case, b squared minus 4ac would be the square of negative 3 minus 4 times 2 times 4. That's 9 minus 32, which is negative 23. Remember what happens if the discriminant is negative? We get no real number solutions. So there are no real number solutions. You have to be careful in this type of problem, and remember that you're not finding the solution. When we looked at x squared minus 6x plus 9 equals 0, we weren't saying that the solution was 0, we were saying the discriminant is 0, and that told us that there was going to be 1 real number solution. We haven't found that solution. Let's look at a couple more examples. X squared minus 2x minus 15 equals 0. In this case, b squared minus 4ac would be the square of negative 2 minus 4 times 1 times negative 15. That's 4 plus 60, which is 64. The discriminant is positive. That means I have 2 real number solutions. What about 2x squared minus 7x plus 2? Well, in this case, the discriminant, b squared minus 4ac, would be the square of negative 7 minus 4 times 2 times 2. That's 49 minus 16, which is 33. Once again, the discriminant is positive. So in this equation, there are 2 real number solutions. I want to look at one more thing about these last 2 examples. We got a discriminant of 64 and a discriminant of 33. 64 is a perfect square. If the discriminant is positive and a perfect square, there are going to be 2 rational solutions. 33 is not a perfect square. If the discriminant is positive and not a perfect square, there are 2 irrational solutions. We haven't seen any of those yet. So what I'm going to do now is turn this over to Steve, who's going to talk about irrational solutions using the quadratic formula.
Hello. As promised, I am going to work with the quadratic formula some more. In Candace's examples, all of the solutions turned out to be rational numbers. In my examples, the solutions are going to turn out to be irrational numbers. So let's start with the equation x squared minus x minus 7 equals 0. If we're going to use the quadratic formula, the first thing we need to determine is what are the values of a, b, and c. Well, a is the coefficient on x squared, which in this example is 1. b is the coefficient on x, which in this example is -1. And c is the constant, which in this example is -7. So let's pull out our quadratic formula from memory onto our paper, and let's go ahead and solve this. X equals the opposite of b, so that's the opposite of -1, plus or minus the square root of b squared, so that's -1 squared, minus 4 times a, which is 1, times c, which is -7, and all of this is taking place over a denominator of 2 times a, which in this example is 2 times 1. So let's simplify. The opposite of -1 is +1. We're subtracting and adding the square root of the square of -1, which is 1, minus 4 times 1 times -7, that's plus 28. And 2 times 1, that part be pretty difficult to mess up. That's 2. So it looks to me like I have 1 plus or minus the square root of 29 all over 2. Now at this point, Candace always broke it up into 2 equations. The reason that Candace broke it up into 2 equations is because the square root part of her expression turned out to be a rational number, and she was able to add that rational number to the integer at the beginning of the expression. In this case, the square root of 29 is an irrational number, and there is no way to combine 1 plus the square root of 29, nor 1 minus the square root of 29. So there's no point to breaking this up into 2 equations. I'm not going to be able to simplify the resultant expressions at any rate. So let's go to our check step. So we need to check 1 plus or minus the square root of 29 all over 2. Let's begin with 1 plus the square root of 29 over 2. If we replace x with that expression, this is what we need to check. Does this expression evaluate to 0? I gotta tell you, the idea of simplifying this expression even makes my hair stand on end. So I don't really think that I want to check this particular equation in this manner. I think what I'm going to do is call on Mr. Calculator Man. So let's use our calculator to check these solutions. Let's begin with 1 plus the square root of 29 over 2. The reason why I need to check my solutions one at a time is because the value of 1 plus the square root of 29 over 2 and the value of 1 minus the square root of 29 over 2 are completely different numbers. Notice that I've gone ahead and displayed a couple of approximations for these numbers. I'm not going to use these approximations per se when I'm doing my check. I'm going to use the memory function of my calculator to do my check. So let's get out our calculator. I'm going to show you the way that the memory works on this calculator. The way that the memory works on your calculator is probably going to be very different. You're probably going to have to get out the calculator manual to see how the memory works on your calculator. I want to tell you a true story. When I first tried clearing the memory on this calculator, I thought all I had to do was press the all clear key. It turned out that that didn't work. So I tried randomly pressing some other buttons, and nothing was working, and finally Ann said, "Why don't you just look it up?" And you know what? She was right. I looked it up, and it told me what I needed to do. After I pressed the all clear key, I need to press the min key to clear my memory. So there's 2 lessons there. One is there's no shame in looking things up, and the other lesson is sometimes a friend or a colleague or maybe even your teacher could help you with your calculator. Alrighty, I've cleared my memory. So what I'm going to do is I'm going to calculate 1 plus the square root of 29 over 2, and I'm going to put that into the calculator's memory. Since I have 2 terms in the numerator needs to be in parentheses. 1 plus 29, take its square root. I'm done with the numerator, so I close the parentheses, divide by 2, and press equals. There is a decimal approximation of 1 plus the square root of 29, all divided by 2. The way I'm going to put that number into this calculator's memory is I'm going to hit the M plus key. Like I say, your calculator probably works a little bit differently. Now I'm going to go ahead and I'm going to clear my screen, and I'm going to check this answer. So let's get the number from memory back on the screen. On this calculator, I do that with the MR key. I need to square that number. Now I need to subtract. Let's get the number in memory back on our screen. And then I need to subtract 7. Before I actually hit 7 equals, I want to point something out. At this point in the calculation, the running total is 7. So when I subtract 7, I know I'm going to get 0. But something annoying is going to happen that we just need to address. So let's go ahead and see what happens on this calculator when I subtract 7. I'm not seeing 0. I'm seeing negative 1.77636 e minus 15. Well, let's remember something we talked about when we were doing scientific notation. Negative 1.77637 e negative 15 is calculator speak for scientific notation, and we can interpret that e negative 15 as times 10 to the negative 15th power. So approximating the negative 1.77 business as negative 1.8, what the calculator is trying to tell me is negative 1.8 times 10 to the negative 15th. Well, what does that number look like not written in scientific notation? It looks like negative 0.140018. I got news for you. That is pretty darn close to 0. Now, in most circumstances, when you want 0, pretty darn close to 0 is not close enough. In this example, it is, though, because 0 is not the real value. It's the calculator that's having issues. This number is called calculator overflow error, and it shows up sometimes when the result is supposed to be 0. So if you're looking for a result of 0 and you see this e to the negative 15, e to the negative 14, e to the negative 16 show up, you need to interpret that as calculator overflow error and realize that the actual value truly is 0. 7 minus 7 is 0. It's not negative 1.77636 e negative 15. So our answer really did check. We need to check our other solution. So I need to clear out the memory. On this calculator, that's all clear, min. Now let's put our value into the calculator's memory. So I need parentheses for my numerator, 1 minus the square root of 29. So 29 square root, done with the numerator. Let's divide by 2 equals. On this calculator, I hit memory plus. Now let's clear our screen. Let's recall our memory. Let's square minus the number in memory minus 7. This time, even the calculator is confirming that the value is 0. Both our answers check, so we can go ahead and state our conclusion, that the solutions are 1 plus or minus the square root of 29 over 2. Let's work another example. In this example, the coefficient on x squared, that's our value of a, is 2. The linear coefficient, that's our value of b, is negative 10, and the constant is 3. So let's apply the quadratic formula. X equals the opposite of b, so that's the opposite of negative 10, plus or minus the square root of b squared, that's the square of negative 10, minus 4 times a, which is 2, times c, which is 3, and this is all happening over 2 times a. So that's 2 times 2. Let's simplify. The opposite of negative 10 is positive 10. We have plus or minus the square root of the square of negative 10 is 100, minus 4 times 2 times 3, that's 24. And this is all taking place over a denominator of 4. So what do I have? I have 10 plus or minus the square root of 76 all over 4. Now you might think the next step is to check these solutions, and there really wouldn't be anything wrong with that, but if you looked in the back of the book, these aren't the solutions that you would see, even though these two solutions really do check. The reason is because the square root of 76 simplifies. There is a perfect square that evenly divides into 76. That is 4. And when I divide 4 into 76, the resultant factor is 19. 19 does not have any perfect square factors, so I'm going to rewrite the numerator as 10 plus or minus the square root of 4 times the square root of 19, and this is all over 4. So this is 10 plus or minus 2 square roots of 19 all over 4. Now I'm noticing something else about this numerator, and that is that 2 evenly divides into both 10 and 2 times the square root of 19. So I want to ask myself, would it help things in terms of simplification if I were to factor 2 from the numerator? And the answer is yes, because 2 is also a factor of the denominator. If the denominator were 7, I would get no value out of factoring 2 out of the numerator. But since the denominator is evenly divisible by 2, if I factor 2 out of the numerator, I will be able to factor 2 over 2 from the fraction and further simplify the expression. So what I'm going to do now is I'm going to go ahead and give myself a little bit of room, and I'm going to factor 2 from the numerator. So picking up, I've got 2 times 5 plus or minus the square root of 19, and this is all over 4, which is 2 times 2. So I can factor 2 over 2 from the fraction, and when I do that, I leave behind my 5 plus or minus square root 19 in the numerator, and a factor of 2 in the denominator, and since 2 over 2 is 1, I really just have 5 plus or minus the square root of 19 over 2. Normally, I would not have shown this step right here, but I wanted to remind you that the reason 2 over 2 can be canceled in this fraction is because I literally can factor 1 in the form of 2 over 2 from the fraction. Of course, now we need to check. And it looks like we're going to do another calculator check. So we need to clear our memory. Do whatever you need to do to clear the memory of your calculator. We're first going to check 5 plus square root 19 over 2. So in parentheses, 5 plus 19, take the square root, done with the numerator, divide by 2, equal, and put the number into memory. Now let's clear the screen, and let's see. We want to take 2 times our supposed solution squared, and then we want to subtract 10 times our supposed solution, and then we want to add, pausing here, I know when I add 3, I'm going to get 0, and I do. Even the calculator is showing 0 this time. So our 5 plus radical 19 over 2 checks. Let's check 5 minus radical 19 over 2. All clear. Min, that's how this calculator's memory is cleared. So in parentheses, 5 minus 19, square root, close parenthesis, divide by 2. What's that equal? Put that number into memory. Now, let's clear the screen. Let's go 2 times the number in memory squared minus 10 times the number in memory plus, I can see that I should be getting 0. Well, this time, I think I've got that overflow error. I need to check what's the exponent on 10 that's being implied. E negative 15, 10 to the negative 15th power. That's a decimal point followed by 14 zeros and a 1. This is just calculator overflow error. The result truly is 0. Both my answers checked, so I can go ahead and state my conclusion. The solutions are 5 plus or minus the square root of 19, all divided by 2. Let's do this again. This time, my quadratic equation has the form ay squared plus by plus c. A, the coefficient on y squared, is 4. B, the linear coefficient, is 5. The constant, c, is also 5. It's time to apply the quadratic formula. X equals the opposite of b, so that's negative 5, plus or minus the square root of b squared, that's 5 squared, minus 4 times a, which is 4, times c, which is 5. And this is all taking place over 2 times a. So that's 2 times 4. So let's simplify. Looks to me like somebody's trying to get my attention. I wonder what's up with that. Can you see what this guy's deal is? Oh, I see what it is. Look at my equation. My equation is 4y squared plus 5y plus 5 equals 0. And I'm saying what x equals. I don't see any x's in my equation, so x don't equal nothing in this problem. I think what's going on is that he's trying to tell me I need to change my x to a y. So getting out my eraser, let's erase the x, and let's replace it with the proper variable, which is y. Now we can simplify. So this is negative 5 plus or minus the square root of 25. Let's see, 4 times 4 times 5 is 80. And this is all happening over a denominator of 8. Holy moly, somebody else is freaking out over something. Well, I'm not quite sure what this dude's freaking out over, so I'm just going to keep on moving through this problem. So let's see, we've got negative 5 plus or minus, let's see, 25 minus 80 is negative 55. Oh boy, I think maybe I see what this guy's freaking out over. We have a negative number under our square root. Well, I have news for this guy. He needs to chill out. This is not really an issue. It's true, there is no real number that I can square that gives me negative 55. So what does that mean? That means my equation has no real number solutions. That's no big deal. It's actually less work because I don't need to check my solutions. So the discriminant is negative. So the equation has no real number solutions. I just threw that word discriminant in because Candace talked about it, so I thought I'd remind you about it, and I also wanted to show off that I could actually spell the word discriminant. Hey, let's look at this equation. I need to use the quadratic formula. To use the quadratic formula, one side of the equation needs to be 0. Notice when the little box flew in, it's kind of giving me a clue that I'm going to make the left side of the equation 0. Why would I choose to do that? Well, it's very deliberate. If I moved the 5x squared to the left side of the equation, the coefficient on x squared would be negative 5. I really don't want a negative value for a, because remember in the quadratic formula, the denominator is 2 times a. And if a is negative 5, the denominator is going to be negative 10. And I really don't like having negative numbers in the denominator. Per se, a negative denominator is not a problem. But for me, it is problematic because it annoys the heck out of me. So I'd rather have a be positive. So I'm going to move all my terms to the right side of the equation. So I'm going to have 0 on the left side of the equation. I already have 5x squared on the right side. When I subtract 10x from both sides, I have minus 10x. And when I add 1 to both sides, I have plus 1. So my value of a is 5, my value of b is negative 10, and my value of c is 1. So let's go ahead and use the quadratic formula. I am closely looking at the equation, and I do see that my variable is x, so I can go ahead and say x equals, let's see, it's the opposite of b, so that's the opposite of negative 10, plus or minus the square root of b squared, so that's negative 10 squared, minus 4 times 5 times 1, all over 2 times a. That's 2 times 5. You know, when I do the quadratic formula, I don't even think about it. It's so embedded in my brain, I don't even have to think about it. The only reason I'm pointing that out is because I want you to know that's the part of your brain that formula should be in too. You should put it in a part of your brain so that we could call you up 5 years from now and ask, what's the quadratic formula? And you could just mindlessly repeat it to us. All right, let's simplify this expression. The opposite of negative 10 is positive 10. Plus or minus the square root of negative 10, that number squared is 100, minus 4 times 5 times 1, that's minus 20, and this is all over 10. So this is 10 plus or minus the square root of 80 all over 10. Now the next thing you have to ask yourself is, since my radical expression does not simplify to a rational number, can I, at any rate, simplify it in some form? In other words, is there a perfect square that evenly divides into 80? Sure there is. 4, but there's actually a larger one, 16. 80 is 16 times 5. So what I'm going to do is I'm going to rewrite the square root of 80 as the square root of 16 times the square root of 5. And once again, I'm going to give myself a little bit more room over here. So this equals 10 plus or minus 4 times the square root of 5 over 10. Now I'm making an observation, and the observation I'm making is that 2 is a factor of both terms in the numerator. Now I need to make the decision. Do I want to factor out that common factor of 2? You betcha. And why do you betcha? Because 2 is also a factor of the denominator, so I can pull 2 over 2 out of the entire fraction. I can rewrite the numerator as 2 times 5 plus or minus 2 square roots of 5, and this is over 2 times 5, so I could pull out 2 over 2, and that would leave me with 5 plus or minus 2 square roots of 5 all over 5. I'm seeing all sorts of 5s. So here's a question. How can we simplify 5 plus or minus 2 square roots of 5 all over 5? Well, we need to ask ourselves a question. Does 5 plus or minus 2 square roots of 5 over 5 equal 5 over 5 plus or minus 2 square roots of 5? And the answer is no, it doesn't. Because if I were to split this up into 2 fractions, each fraction would need to have a denominator of 5. I'd have to write this as 5 over 5 plus or minus 2 square roots of 5 over 5. So the first occurrence of 5 in the numerator does not simplify with the 5 in the denominator. The first occurrence of 5 in the numerator is a term of the numerator. It's not a factor of the numerator. You can cancel common factors. You cannot cancel common terms. Why can you cancel common factors? Is 5 a factor of 5 plus 2 square roots of 5? The reason this is the relevant question is because if 5 were a factor of the numerator, I could rewrite the fraction as 5 over 5 times the 2 terms in the numerator factored by 5 over 1, and 5 over 5 is 1. So is 5 a factor of the numerator? Well, you might think it is because you see a 5 in both terms, but it's really important that the 5 in the second term is underneath the square root symbol. And so we don't have 5 in the second term, we have the square root of 5. And the square root of 5 is an irrational number that's approximately 2.236. So ask yourself this question. Can you factor 5 from 5 plus 2 times 2.236? Well, that's kind of a silly question. When we talk about factoring numbers, we're talking about natural numbers. We don't have a natural number here. So no, 5 is not a factor of the numerator. Since 5 is not a factor of the numerator, we cannot simplify this fraction. So now we need to check 5 plus or minus 2 radical 5 all over 5. I'll do one of them and leave the other check for you. So I need to clear my calculator's memory. In parentheses, I need to find 5 plus 2 times 5, take its square root, done with the numerator, divided by 5 equals, dump that number into the calculator's memory, clear the screen. Now, one way I could check this equation is I could evaluate 10x minus 1, write down the decimal result, then evaluate 5x squared, write down the result, and compare those two numbers. But I think a little more efficient way to check this equation is to do the trivial step of subtracting 5x squared from both sides of the equation and seeing that 10x minus 1 minus 5x squared evaluates to 0. Alrighty, I already put my proposed value of x into the calculator, so let's evaluate our expression. 10 times the number in the memory minus 1 minus 5 times the number in the memory squared equals 0. Check-a-roo. Remember, you need to check 5 minus 2 square roots of 5 over 5 as well. After you've done your check, go ahead and write your conclusion. And the conclusion is that the solutions are 5 plus or minus 2 square roots of 5 all over 5. Now, Candace and I have just shown you several examples using the quadratic formula. I suggest, if you're watching this on tape, that you pause the tape and go do your problems out of the quadratic formula section right now. Because what Anne is going to do is she's going to remind you of all of the different solution methods, and then she's going to tell you ways that you can make choices when choosing the way you're going to solve the quadratic equation. You'll get more out of her lesson if you're already really familiar with the quadratic formula.